The influence of temperature on crystal oscillator frequency. The nominal frequency of a crystal oscillator has an error, which is measured in parts per million, ppm. Common crystal oscillator errors include plus or minus 10 ppm, plus or minus 20 ppm, and plus or minus 30 ppm. For example, a 20 MHz plus or minus 10 ppm crystal oscillator has a frequency range of 19,999,800 MHz to 20,000,200 MHz. In addition to the frequency error of the crystal oscillator itself, changes in ambient temperature can also cause the frequency of the crystal oscillator to change. This parameter is called the frequency temperature stability of the crystal oscillator. For example, the most common at-cut quartz crystal oscillators have a frequency deviation curve with temperature changes like this. The previously mentioned crystal oscillator error refers to an error in an environment of 25 degrees Celsius. As you can see from this curve, when the temperature is 25 degrees Celsius, the frequency deviation caused by temperature changes is zero. When the temperature is above 25 degrees Celsius, the frequency deviation of the crystal oscillator decreases first and then slowly increases. When it reaches the highest operating temperature, the frequency deviation becomes the maximum positive value. When the ambient temperature is below 25 degrees Celsius, the frequency deviation of the crystal oscillator increases first and then decreases. When it reaches the lowest operating temperature, the frequency deviation becomes the minimum negative value. As for the oscillation circuit of the crystal oscillator, the selection of these two load capacitors generally requires the use of capacitors made of C0G or NP0 material because the capacitance of capacitors made of C0G or NP0 material changes relatively little with temperature. The capacitance of these two capacitors can affect the resonant frequency of the crystal oscillator. Therefore, using capacitors made of C0G or NP0 material can reduce the impact of temperature on the resonant frequency of the crystal oscillator. In addition, the capacitance tolerance of these two capacitors is generally small, usually less than 2%, so the consistency of the capacitors will be better. The consistency of the resonant frequency of crystal oscillators on different boards will also be better.